Okay, part 5 here, we're going to be looking at acceleration. We need to look at what makes it so much different and unique from speed and velocity, which you should have already learned in the previous sections. Okay, so now we're going to be looking at acceleration. And notice the definition in acceleration is the rate at which your velocity changes. Notice we said rate. Well, remember, a rate is something over time. Velocity was the rate at which displacement change, but this is the rate at which velocity changes, because we all know you can change your velocity. For instance, if I'm down here and I'm riding on my bike, and for every second that goes by, I increase by 1 second, or 1 meter per second at a time. 5 meters per second is a big difference from 1 meter per second. But it took me 5 seconds to do that because I'm speeding up. I'm getting faster. So you understand the concept that you're getting faster. So that's what acceleration is. But let's take a look at a very classic example. So to get a better look at acceleration, let's take a look at an acceleration that almost everybody knows, gravity. Okay? So gravity, if you don't know this, has an acceleration that things come to the Earth, and it's 9.8 meters per second squared. That also can be written as 9.8 meters per second because it is a change in velocity over time. So it is an acceleration. Now, don't get too caught up on that just now. In fact, even though that's the correct one, we're going to go ahead and make it a little bit easier. We're going to round up, and we're going to say that gravity is equal to 10 meters per second squared. And I do that just so we can get the basic idea of it. So here's a classic scenario. There's somebody, like Mr. McCollum, pay no attention to why his avatar looks so angry, but decides to drop something, a cell phone in this case, off of a cliff, a really big cliff. Okay? Now, on that really big cliff, as it falls, it will keep falling ever so often until it's at a new spot. If we were to look at its speed after every second that it dropped, so that's 1 second of time, when I first let go of it, its speed is 0 meters per second. But because of gravity, and I dropped it after 1 second, it's now equal to 10 meters per second. Because remember, we said we rounded gravity up to 10 meters per second squared. And then after 1 more second of falling, so Mr. McCollum's cell phone is now right there, boop, boop, boop. Its speed would now be at 20 meters per second. And it would continue doing that as far as it could fall. So that was 1 second too. If this is 1 more second, that cell phone would now be at 30 meters per second because it's accelerating at 10 meters per second every second. That means once it starts to fall, if you count seconds, it's going to increase by the amount of velocity every second that it goes. We use this all the time. Think about in trying to find a really fast car. A lot of people are like, oh, I want a really, really good car. And so they start to talk about things like, I want one that goes from 0 to 60 miles per hour in 3 seconds. Well, this is its speed or velocity if you give it a direction. And to say that it's going to change that much in 3 seconds, well, you're saying it's changing a velocity of 0 to 60 in 3 seconds. So it accelerates at 60 miles per hour every 3 seconds. So you could actually do that, and you would get that it has an acceleration of 60 divided by 3 is 20. So it's 20 miles per hour per second. And that's funny units because it's not SI units, but it's the basics of acceleration. Let's look back at some things to remember. So velocity and acceleration, they're not the same thing. Acceleration is the rate at which velocity changes. You need to understand that you can be moving non-zero speed and have no acceleration. If you're going at constant velocity, your velocity is not changing, so you would have no acceleration. Think cruise control, right? You can also be accelerating and not move from that space. Because acceleration is a vector, meaning it changes direction, think about if you spin around. You're technically not changing your displacement anywhere, but you are accelerating because you're changing the direction you're facing. All right. And a falling object begins accelerating the instant it's released. So in this case, someone that's not depressed Avatar Chris is dropping the ball in gravity. And so it starts at zero. As soon as it's released, it starts moving.